we proudly introduce our technologies for assay-guided molecule sequence generation. Our powerful assay-guided molecule and sequence generation is performed by creating deep learning-based search space, incorporating your assay data. As your assay data can guide directions for generations, our experience with collaborators is that better molecules and sequences are generated as the multiple round progress. We have developed assay-guided search and generation systems for PPI inhibitor molecules, kinase inhibitors, antibody sequences. Our powerful assay-guided molecule and sequence generation systems are deployed on Amazon Cloud. All you have to do is to create an account on Amazon Cloud and copy our pre-configured system images. In this way, your data is securely protected with Amazon technologies. Now we demonstrate our system for assay-guided PPI inhibitor generation. Our system is developed and configured to generate effective orthosteric PPI inhibitor to block interaction between two proteins. In 2 or 3 rounds of navigation, you will be amazed to see how much your current molecules are improved. We can build more comprehensive packages for you. For example, we can evaluate toxicity using cutting-edge technologies. Now, let me walk you through the 6 steps we use to generate PPI inhibitor candidates. First, we begin with molecule generation. Second, we apply a filtering process to narrow down these candidates based on their molecular properties, things like drug likeness. Third, the filtered molecules undergo docking simulation to predict how well they bind to the target protein. Fourth, we conduct residue-level interaction analysis. Fifth, we estimate drug-target affinity. And finally, in step 6, we combine the drug-target affinity predictions with your own assay data. Molecule generation is done by multiple different approaches so that diverse molecules can be generated and explored.
Let's execute round 1. The first thing you have to do is to name your project or workspace. Now we will generate molecules as PPI inhibition candidates with 3 different molecule generation methods. To begin, you'll need to input parameters for each step. For step 1 molecule generation, upload your target protein file. Specify the key residues, and set the number of molecules you want to generate. Step 2 filtering molecules. Generated molecules are filtered in terms of desired molecular properties and our novel ADME drug likeness score. Step 3 docking simulation is done for the molecules by specifying target protein PDB file and ligand ID and chain or center coordinates of searching box. Step 4 further filtering based on atom, residue level interactions by specifying residue level interactions between the target protein and candidate molecules. Step 5. Drug target affinity. Candidate molecules after residue level filtering are examined by predicting drug target affinity values using our novel in-house drug target affinity tools. You can examine multiple proteins by selecting protein IDs in RDB. Step 6 fitting DTA prediction with your assay data by specifying your assay data in CSV format. DTA models are trained using public data. Thus, it is important to fit in your assay data so that DTA prediction can fit in for the protein target of your current interest. Now, let's explore our assay-guided search in more detail. The first approach for generating PPI inhibition molecule candidates is to use hotspot-guided molecule generation. That ensures interaction with key residues specified by the user. The second approach is based on our novel fragment-based molecule generation technology, MFrag, presented at ICLRML Gene X 2024, which is now in submission to a leading journal. To reflect your assay results, we use our in-house subgraph or fragment mining technology published in iScience 2023. Candidate molecules are generated by combining and evaluating fragments directly from your assay results. The third approach is based on our novel molecule mining technology published in CSBJ 2023. This method is to mine large chemical databases such as zinc or your own compound libraries by exploring chemical similarity networks, starting with active molecules in your assay data. We have reported our success in identifying and confirming 2 CLK1 inhibitors from zinc. We further developed and used our chemical network mining technology, SubDive, to reflect your assay data more effectively, which is in review for NeurIPS 2025. Here we show screenshots for molecule generation. Now we generated candidate molecules for 20,000 PPI inhibitors. Each of molecules are filtered based on molecular properties, synthetic accessibility score and drug likeness. Additionally, our in-house drug likeness evaluation method based on a DME assay refined chemical space, ISMB 2025. The user can specify various molecular properties for filtering. Additionally, candidate molecules are evaluated in terms of chemical space of approved drugs that are refined by a DME assay data. Evaluate how well candidates fit in pockets of the target proteins. In current standard configuration, we used Autodoc Vena. Here we show screenshots for molecule docking. You can visualize the predicted binding poses and affinities of candidate compounds in a dynamic 3D simulation environment, helping you gain deeper insights into molecular interactions. After docking simulation, the user can examine how well candidate molecules interact with the target protein at the residue level. Here we show screenshots for residue-level interaction filtering. After residue-level interaction filtering, the user can reduce the number of candidate molecules to a more manageable set. These molecules can then be easily sorted based on drug target affinity values or other criteria. Filtered molecules are evaluated in terms of drug target affinity. For these, we use our in-house cutting-edge technologies, CheapNet, ICLR 2025, and Mixing DTA, ISMB 2025. Here we show screenshots for drug target affinity prediction results, generated using CheapNet and Mixing DTA. At this stage, you can review the intermediate outputs, including the predicted affinity values for each candidate molecule. Now it is very important to test DTA results using your assay data, because CheapNet and Mixing DTA are trained using databases in the public domain. We combined 6 DTA prediction values from CheapNet and Mixing DTA into one DTA prediction value using AutoGluon. Now, candidate molecules are ranked according to the DTA values. As shown, DTA prediction values are highly correlated with your assay data.
Now we have a prioritized list of candidate molecules. We will show you how the next round molecule generation proceeds. If you selected and synthesized 100 candidate molecules, assume that 40 molecules are active and 60 molecules are inactive. We will create embedding space for your molecules using our in-house novel technologies. Predicting drug likeness via biomedical knowledge alignment and EM-like one-class boundary optimization, ICML 2025. Now we show how assay-guided search with results from round 1. We create a deep learning-based embedding space, where all molecules are placed using our powerful in-house deep learning model to be presented at ICML 2025. Putting in newly synthesized and tested molecules in the embedding space, we are excited to see that active molecules are clustered in a specific direction. This is real data from our collaboration with a renowned medicinal chemist in Korea. Let's execute round 2. To get round 2 started, you can simply upload your assay data from round 1. With new assay data from round 1, molecule generation in round 2 is further guided. First, hotspot-guided molecule generation can utilize the embedding space so that more likely active molecules are determined in the embedding space. For fragment-based molecule generation, More refined substructures or fragments are used to generate new molecules. The data mining for active molecules can utilize the new assay data from round 1 for the construction of chemical networks for mining active molecules with more refined substructures or fragments. After being generated by the newly updated model trained on assay data, candidate molecules undergo a rigorous filtering process and detailed docking simulations to assess how well each molecule fits into the target binding site. Residue-level interaction filterings, and are ultimately prioritized based on their predicted binding affinities. Effectiveness of assay-guided search. We performed round 1, 2, and 3 with our collaborators, demonstrating significant improvement in molecular activity. We are ready to explore chemical space in collaboration with you. We are your trusted partner in drug discovery. iGen Drug.